Unit 5, guys, let's do this. Okay, functions defined on the closed interval, the graph of its derivative. Guys, anytime you see a graph, make sure you know what you're working with, right? You can write it really big or remind yourself it's derivative, whatever. At what value of x does the absolute minimum occur? Okay, we need to talk about this a little bit more. I'll try to bring it up quite a bit this week. When you guys see that word absolute, absolute max or absolute min, I want you to think two things. They can occur at endpoints, which in this case, the endpoints are 0 and 8, because it told us that, or they can occur at critical points. Now, the critical points, the definition of that is when the derivative equals 0. This is the derivative. So it could be there or there, okay? That could be at 4 or 6. So what I do is I will either, if I have a way to plug it in, you guys, I don't on this, but if I had a way to plug it in, I would actually plug in those values and try to figure out which one was the absolute max, okay? If I don't have a way to plug it in, now actually for my sine line graph, I should end this in brackets because that'll show my 0 and my 8, and then I'll have my 4 and my 6. And here's the thing, okay? This is a sine line graph for f prime of x. When I'm checking it, it's like, okay, if I plug in 2, that's a positive value. If I plug in 5, that's also a positive value. If I plug in 7, that's a negative value. So look, I'm going positive, positive, negative. So where's my absolute max? Right here at x. Okay, that's how I would do that. But remember, the word absolute is going to tell you endpoints critical. Okay, cool. Here's another absolute. I'm guessing this is what this section is going to be on a little bit. Absolute. Okay, endpoints, critical points. Right? My endpoints are 0 and 9. Let's find my critical points by taking the derivative. That's going to be x squared minus x plus 12, 0. I could factor that. That's minus 6 minus 2. So x is 6 and, okay, endpoints critical. Now, you guys, you should be able to do either way. You should be able to plug these in, or you should be able to do a sine line graph. Okay? Shoot. I do not want to plug in every single one of these to here. Plug. I mean, like, it wouldn't be too bad, but it'll take me a second. Let me do a sine line graph real quick. And again, it's on a closed interval. That should at least narrow it down for me, okay? 2, 6. All right, check it out. We're graphing from the derivative, looking at this part right here. If I plug in 1, that's a negative. If I plug in 5, that's a negative positive. And if I plug in 8, a positive. Like it goes, I have two possibilities, okay? Here, that could be my absolute max, or here, that could be my absolute. Now, if we're talking about local max, you guys, local, okay? But absolute can occur on endpoints, and how do I know which of these go higher? I don't. So, someone would get absolute and one of those two, 9. Those are the only ones I need to. All right? So I'm going to come over here. Let's see here. I'm going to plug in, let me start with 9 because that's like a pain. 1/3 of 9 to, usually 4 times 9 squared plus 12 times 9 minus 5. Okay, I was just making sure they were both options because maybe I could narrow one down. Okay, well, anyway, 9 times 9 times 9. One of those threes will cross with one of them. That's what makes the lilies here. 81 times 3, so that's 43. 9 squared is 36 times that. I don't know, you guys, if it's no calculator and we are feeling a little brain dead, we just got to go old school, right? That's 144. That's 108 minus 5. Oh man, okay, I think I can figure that out. It's 243 minus 144 is 99. I mean, this looks like it's going to be the largest, but let's just see. That's going to be 207, so that's going to be 202. Dude, I did not like that. All right, now we're going to plug in the value at. Hopefully this will be a lot better. Let me go down. Okay, so f of 2 is going to be 1/3 the 8. 4 times 2 squared is 4. 12 times 2 minus 5. I mean, maybe they were hoping I'd be smart and just realize that there's no way this is going to get that big. But that's 1/3. So that's 8/3 minus 16 plus 24 minus 5, which is going to be 3. 8 minus 5 is 3 plus 8/3, which is going to be like, I don't know, what's 8/3? 2 and 2/3? This will be like 5 and 2. I mean, regardless, right? This is clear. And like, there should have been. Here we go. Okay. All right. We got a graph. What is this a graph of? Before I even read, F is shown in the figure above. Which of the following is true? Okay, check this out, you guys. At 1, so I'm going to evaluate. I'm going to see what's going on right here. F of 1, that just means the point on the graph. And the point on the graph is 0. F prime of 1, what does that mean? Prime tells me slope. That is a positive slope. F double prime 1, though, that talks about concavity. Okay, and this entire graph actually is concave down, and concave down is negative. But when as you order things, it's typically going to be like one will be negative, one will be 0, one will be positive, right? So F double prime is the smallest. F of 1 is in the middle because that's 0. F prime. So F double prime is the smallest. Okay, so that's going to be D. So that would be D. Okay? So just kind of checking your understanding of what each of those are. All right. Let G be a twice differentiable function. Okay, I'm going to actually interpret that right now. If the derivative is greater than 0, it's increasing. If the second derivative is greater than 0, it's concave up. Okay, now we have G of 4 is 12, G of 5 is 18. I just like to picture this. 4, 12, 5, 18. So it's getting bigger, that's getting bigger, okay? Now, all right, you guys. Increasing means that 6 would have to be above 18. You guys see that? So the fact that it's increasing means that this point up here, 6, would have to be something bigger than 18. And it couldn't be equal to 18 because then it's either going to go straight across or back down. So I can get rid of those two. Okay, now the concavity. Okay, we got to think about this. In order for this to be concave up, right? The slope. Okay, we're gonna look at the slope. The slope here has to be steeper than the slope here, right? Like, if that goes like that, and then if it goes less, that's not going to be concave up. And if it goes the same, it won't be concave up. It has to go that way. It has to be steeper. So I'm going to look at the slope right here. So 18 minus 12 over 5 minus 4 is 6. So those have a slope of 6. So whatever point this is, 6 comma something, the slope needs to be bigger than 6 from like 5, okay? Or from before 12, it doesn't really. Maybe I'll go from 412. Okay, so something minus 12 over 6 minus 4, and it has to give me a number that is bigger than 6, because the slope down there was 6, okay? If I put 21, that would give me 9 over 2, which is 4.5. That's no good. If I put 24, it would give me 12 over 2, which is exactly equal to 6. That's no good. Okay, but if I used 27, that gives me 15 over 2, which is 7.5, which makes it go concave up because it has a sleep. Steeper road. There we go. All right. All right, I had to pause, and so I just checked my answers when I paused, and I realized I am such a dope. Did you guys see that I got this one wrong? And you know why I got this one wrong? Because I didn't read very well. Look, I never make math mistakes. No, I'm just playing. I make math. But I make reading mistakes more than I make math mistakes. It wanted the minimum, not the maximum. Gosh dang it. Definitely not at 6. It's either at 0 or 8. So that was my bad. Now, how do I know if it's at 0 or 8? Okay. We actually do have to think a little bit more on this one, unfortunately. I know it's not going to be 4 or 6, but I got to think here. So let's say this is like some value at 0, right? Okay, let's say that the function, because this is a graph of the derivative, let's say f of 0 is something. I don't know, it doesn't matter. 10, right? Let's say it's 10. Okay, now check it out, guys. I'm adding a whole bunch of stuff to 10. I'm adding. So I have a number much bigger than, and then I'm adding a whole bunch more stuff. So I have a number even bigger than that. And then I'm subtracting this little teeny tiny bit. So which is going to be more, the 10 or that little, or the amount over here or the little teeny tiny bit that I'm getting over there, right? So obviously if I have 10, I'm adding a whole bunch. Maybe that goes up to like, I don't know, adding a little more. Maybe it's 25. I'm taking off a little bit. Maybe it's back down to 20. So like I'm just estimating here, but 8, the actual function could be at 20. For the function of 0, I start off at like 10. So the minimum, the smallest, is going to be adding it. Okay? Sorry, that's -1 for Mitchell. Okay, sorry about that. I don't want to re-record the beginning, so. Alright. Boom, 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 boom. Okay, let's take a look at number 5. F of x is ln of x over x, only on the positive side of the axis. We're looking at increasing, decreasing. So increasing, decreasing, that's cool. I could do a derivative here. Now I am going to have to do a quotient rule. Remember the quotient rule goes derivative of the top times the bottom minus top derivative of the bottom over squared. Okay, here the x's cancel out. So it's 1 minus ln of x over x squared. But we've done a question like this before. I'm going to go ahead and make a sine line graph. I'm going to put this as 0 though, because it doesn't go below 0 and it can't equal 0, okay? Now guys, when you're doing your sine line graph and you have a fraction, up here are possible critical points where it equals 0 or are critical points. So 1 minus ln of x equals 0. So 1 equals ln of x. And when I solve that and I do it to both sides, x equals. You also, though, have to think about this. Now, here's the problem. That's an undefined point at x equals 0, so I would at least need to do something with it on my sine line graph. Luckily, it's an endpoint, so I don't have to worry about it. The only thing I really got to worry about is x equals e. Now, remember, e is about like 2.7 or something, okay? So when I'm actually going to do the, like, sine line graph of like plus minus, and I'm testing into the derivative, okay? Set for a minute. All right, something less than e, I'm going to use 1. That's certainly easy, especially because the ln of 1 is 0. When I plug in 1, 1 minus 0 is positive, 1 squared is positive, so it's positive. Now I need to plug in something bigger than e. I mean, could I pick 10? Sure, I just don't really know what the ln of 10 is, like, in my head, you know? That's a little tricky. So I'm going to actually plug in e squared. Do you agree with me that e squared is bigger than e? Okay, so check this out. 1 minus the ln of e squared. Well, ln of e squared cancels out, and so 1 minus 2 is negative. E squared squared is positive, so this is negative, okay? So I'm increasing, decreasing. Increasing for all x, that is definitely not true. Increasing greater than 1, that is not true. Increasing between 0 and 1, that's not true. Decreasing between 1 and e, that is not true. Decreasing greater than e, that's true. Everything bigger than e. Yep. All right. Okay, this looks interesting. What have we got here? Oh my goodness, this looks weird. All right. See what I can interpret from up here. If y is a function such that derivative is greater than 0 for all of x, what does that mean? It's increasing always. Derivative greater than 0 for all of x. Okay, Second derivative is less than 0 for all of x. What does that mean? It's concave down always. Line could be part of the graph. All right. Let's start with increasing, okay? Is that increasing? Yes. Increasing? Yes. That's decreasing. That's increasing and then decreasing. Increasing. Yes. Okay? So I could have A, B, or E. Now, it's always concave down. Remember, concave down spills water. Concave up holds water. So let's see. Test that. That's concave up. So that's up. That is constantly concave down. So that's good. That's up and then down. But see this part right here? That's concave up. So we're definitely going to choose B for this one. Okay. Ooh, this looks fun. Okay, so now we're going to be on our free response questions. All right. The graph of a continuous function of g, the derivative of f. Okay, so hold on a second. I need to know that. G is the derivative of f. Okay. The function g is piecewise linear. That means those are all straight lines. And then it's that equation from 3 to 6. So basically, you guys, this part right here is a parabola that's 2x minus 4 squared. And then the rest are just lines, okay? Okay, 4, on what open intervals is the graph of f increasing concave up? Give a reason for your answer. Okay, so let's, again, go back to the vocab. Always go back to the vocab. F is increasing if I could show f prime is positive, okay? Or anywhere where f prime is greater than 0. F is concave up where f double prime is positive. And what does that mean? Okay, well, that means that if f double prime is positive, it means that f prime is increasing, but like a kind of a weird way of saying it. But another way of saying increasing is like f double prime is the slope of f prime. And if the slope of f prime is positive, so I kind of like that way better. Rather than saying that, I think I'm going to say if f prime is greater than 0, and then if the slope of it is also greater. Okay? So looking up here, now f prime, you guys, is the graph of g. So I could just say that this is f prime. Okay? Where is it positive? Okay, I'm going to like kind of highlight the spots where it's positive. Not there because it's like equal to 0, but there's positive, 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 and positive. Okay? So it looks like f prime is positive from basically only from like 0 to 6. Now, where is the slope of f prime positive? So remember our guy, our snowboarder guy? Those are positive slopes. Those are 0 slopes. Those are negative slopes. Positive. So it looks like it's above the axis and it's positive here and here. Okay, so I'm thinking it's 0 to 1, 4 to 6. Okay, above the axis and the slopes are increasing. Oh yeah, this is not more. So I'm going to go 0 to 1, 4 to 6. Give a reason for your answer. Okay, give a reason means justify, so let's think about this. F of x is increasing when f prime of x is positive, and f of x is concave up when f prime of x is, when f double prime of x is positive. Or you could say when f prime is increasing. Two different things. Okay? Increasing concave up. All right. 8 looks like we're looking at the same graph. On what intervals is f decreasing in concave up? Okay, so f is decreasing when f prime is negative. F is concave up when f double prime is positive. Another way of saying that is the slope of f prime is positive. Let's look at where f prime is negative on my graph. Let's use some different colors here. It's negative here to here, negative 5 to 1. And out of there, where is the slope positive? Okay, my slope is positive right in this little section. So the below the axis positive, the x values are negative 2 to negative. -2 to -1. And then I would just say my same thing, which I kind of said there, but like write it out better than that, right? F is decreasing when F prime is negative. F is concave up when F double prime is positive. Like I said. All right. Cool. Let's look at number 9. We got some semicircles and some lines. Oh, there's a graph. I need to make sure I know that the graph of F prime. And it tells me F of 1 is 3. That's good. The graph of the derivative consists of two semicircles, 2 lines. Find all values where F has a relative max. Okay, cool. So you guys, relative max, we need to do a sine line graph of the derivative. Now this is closed from -5 to 5, so I'm going to go past there. And let's see where the derivative equals 0, okay? Here, here, and here. So at -3, 1, and 4. And now I'm going to draw my plus and minuses, okay? Well, between -5 and -3, it's above the axis. That's positive. Then it's below the axis. Above, below. So it's going to go increasing, decreasing, increasing, decreasing. Find all values where it has a relative max. Okay, look, here and here. Okay, so here's how I'd write it. F of x has relative maxes at x equals -3 and x equals 4 because at those points, f prime of x equals 0 and f prime of x changes, this is important, okay, from, now what is it changing from? Positive to negative, right? Guys, that's just as important, writing that up, right? Typically, you're going to get a point for the answers right here, point for the answers, and then a point for that, okay? Okay, sweet. 10 is its own question, so let's take a look at that. And 11 is its own question. All right. An isosceles triangle whose base is on the interval from 0, 0 to C0. And then that's going to be like up there. Has its vertex on the graph of F. This is tricky. Now, you guys, I happen to know what that looks like. I'd like you to know what it looks like. Basically, an upside down parabola that's 12. Okay. So that point is the point x comma y, but y is 12 minus x squared. Okay? What value of c does the triangle have a maximum area? All right, so first of all, I'm in x's and c's. This is a little bit weird. I want you guys to picture this real quick. If this is 0, and then the base goes to c, what is halfway between? What x coordinate is halfway between 0 and c? I mean, if I said to you guys, what's halfway between 0 and 10, you'd be like 5. What's halfway between 0 and 15? You'd go 7.5. But what's halfway between 0 and c? C over 2. So the x coordinate is actually, let me write it like c over 2, comma, 12 minus c over 2 squared. That's the coordinate of that. Okay, are we good so far? All right, this is definitely a tricky one here. Now, what is the area of an isosceles triangle? The area of an isosceles triangle is 1/2 base, what's the base right there? C, times, what's the height right here? Over 2. The height is the y coordinate, which is 12 minus, I'm just going to write that as c squared over 4, if everybody's cool with that. And that's my area equation. Now, let me simplify this a bit. That's going to be 6c minus c to the third over 8. That is my area equation. How do we maximize anything, you guys? Think about this. Maximizing something means, like let's say it has like a graph like that or something like that, it's that point. So how do we find max and mins? Where the derivative is 0. That's what gives us max and min. Okay? So I'm going to go ahead and, which is 6 minus, the 8 can just stay over there, right? So 3 8 squared. Is that equal to 0? Okay, I'm going to subtract the 6, multiply by 8, divide by -3, and c could be plus or minus 4. All right? Except that we know it goes over here. So for what value of c does the triangle have a maximum area? The okay, justifying this. Now, I do actually have to make a fine line graph to justify this. Now look, c can't be less than 0. I don't know if it has an upper bound, but that's fine. So I'm going to put a 4 right here. And then I'm going to test it. Now remember though, we're testing into the a prime. So if I test the number, let's say I test the number 2, I would get 6 minus 12 over 8. That's going to be a positive number. Let's say I test the number 10. Let's say I get 6 minus 300 over 8. That's going to be a negative number. So the justification is that it increases, or it changes from increasing to decreasing. So justify always a prime of x changes from positive at e equals 4. Therefore maximizing the area. Right? Okay, cool. Some of these are tricky, man, but I like them. And mean value theorem. Okay, you guys got to memorize that. What mean value theorem means to me is derivative, like calculating it. Oh, this is the same question. Oh no, this is this question. Okay, sorry, I missed that. All right, let me write that a little bit bigger. On the interval 1 to 3. Okay, so we go like this. F of b minus f of a over b minus a, and it equals some c where there's a derivative there. All right? So I'm going to start with finding that's 27 minus 7 times minus. I really hate doing this stuff in my head. All right, 27 minus 63. 36, negative 36 plus 6, 30. F of 1 is 1 minus 6, which is 0. So I get negative 3 minus 0, 1. So I get negative 32, which is negative. Now that is what f prime of, okay, well let's go ahead and take the derivative. Here's f, write it over here. The derivative of that is going to be 3x squared minus 14x. Nope, 3x squared minus 14x. 6 goes away. Okay? And when it says f prime of c, I mean, I should change it into a c. It doesn't really matter. There we go. And now I have to solve that. Guys, the only way to solve quadratic and factor it. You can factor that way. You could factor this way, whichever one you remember. 3 times 15 is 45, 14. That's minus 5 minus 9. Divide by 3. Remember it that way, great. If you remember it the other way, we basically just go 3x, x, 5, 3, minus, minus. My values are at 5/3 and 3. The last thing is with mean value theorem, though, those have to be in the interval. and I mean 3 is not in that interval because it's an endpoint. The answer should be x is 5. Okay, look, those last 3 questions, those were tricky for sure. Those 3 responses were very difficult. But remember, you know, if you're looking at passive, just trying to pass, right? Can you do half of the points on there, you know, or half of the question? All right? All right. Whew, good work. That was a tough one. All right, stupid correction corner, everybody. I'm gonna have to take a nap before I do any more of these. I majorly messed up number 8 because I thought number 8 was talking about that graph. Did you guys all notice that? So I actually did not get this wrong, okay? I didn't get it wrong, but I got it wrong because, jeez Louise, I was looking at that graph rather than looking at the fact that it gave me this new equation right here. Jeez. Okay, look, I'm gonna blame that on the spacing on this stupid page, which you guys should be annoyed about too. And guess what? I will fix it for next year, not for you guys. Sorry, my friends. Way it goes. All right. So now I can redo number 8. Look, if you already did it the other way, it's fine. I'm not that worried about it. All right. Okay, the derivative of the function of given by this. So f prime is x minus 3 e to the x. Now look, that only equals 0 here because e to the x can never equal 0. So it only equals 0 at 3. E to the x is always positive. So if I plug in something less than 3 like 0, it's going to make that negative positive. And if I plug in something bigger like 4, it's going to make that positive. Okay? That's my first derivative. Here's my second derivative. I got to do a stinking product rule. Derivative of the first times the second plus first times second. Again, remember I was telling you guys that anytime you're doing derivatives and you have like an e to the x in each term, what we like to do actually is we like to just factor that out. So it says e to the x, and then I'm going to factor that out, I get 1 plus 3. And I factor out the e to the x. Okay? Well, I could simplify that a little bit. I could say that that's x and then x minus. So where is that going to have a possible inflection point is at a negative 2. And when I turn 0 would make that either on positive, negative, and then, I don't know. So this is now asking me for decreasing, which is anything less than 3. Decreasing is anything less than 3. But concave up is positive, which is just going to be anything bigger than. So it's basically going to be x is between 2 and then to explain your reasoning, you know, f prime is negative and f double prime is positive. Okay, so my bad on that one. Okay, you guys, did you notice that when I took this here, I copied it wrong? So that's dumb, but I'll be straight honest with you. My answers are way better because if you do it with that, it's actually really a terrible, it's a terrible problem. You come out with like a square root. So, can we say that we just like mine better and do it that way? Is everybody fine with that? Okay, fine with that. If you did it the other way, the answer was like 3. And I can show you guys if you want. Well, I'll do it really quick for those of you that are like compulsive, or compulsive, obsessive. I don't know. Otherwise, you're done. Let's bust this out real quick though. X to the third minus 7x plus 6 1. Okay, I'm gonna redo this. X to the third minus 6. Okay, so here's what we got. F of 1 is 1 minus 6. F of it is 27 minus 6. Oh, so my is f of b minus f, I guess. My derivative is 3x squared minus 7. And now I set the slope equal to the derivative. So I go 3x 6. I got to solve this. That equals 13. That's 13 over 3. So x is the plus or minus, but the only one that is actually integral is the positive square root of 3. That's a 2-for-1. Okay, I got you both different types of questions based on my mistaken one, and so maybe you think that one's easier if you're better. Anyways, okay, good. We're done. Peace.